Hi everybody, here we're going to go over the general instructions and for how to complete the gravity lab. So there's an actual set of written instructions, and that's going to be posted on Blackboard as a PDF file, and this is what it's going to look like here. So it's going to be, I believe, 3 pages. So these are going to be the actual instructions that you're going to read, and you're going to concentrate on the experimental procedure here, number 1, 2, all the way up to number 8. And in the instructions, there's also a theoretical section that you should read, and you're going to apply, you're going to use equation 3.1 and 3.2. So these are going to be the instructions for the lab, but I'm going to also give you an overview of how to complete the Excel spreadsheet. So let's go ahead and look at the next part then. So here, once you open up the Excel lab, make sure you enter your student ID, your capital number, capital letter, and then the numbers. And then the next thing is there's an internet link. You can either type this into Google, or you can click on this link over here. And when you do that, this page here is going to show up. And you're just going to click on this image. And then you're going to click on intro. So, and this is going to be where you're going to perform the lab. You're just going to move this thing side to side, and you're going to make some adjustments and take some measurements. But we'll come back to that in a little bit. So let's see the different parts of the Excel spreadsheet. So first of all, you have your error measurements. So the different components are digital, the length digital display. That's going to be on this FET website here. And right there, this is going to be that number here. That's going to be the digital display for the length. So this first number here, that's changing. Don't use a ruler to get the error. Use the actual error use the actual reading for that digital display. Next, you have a stopwatch. So let's see, we're going to get the stopwatch. Just going to click over here, stopwatch, and you can just let the thing run and stop it. And from there, you're going to calculate the error for that digital device. And remember here, the last digit is not fluctuating, so refer to the error analysis lecture in order to find the error for the stopwatch based on that. The next device is going to be the mass display. So here, that's just going to be this digital mass setting here. So whatever number you see there, again, consider that that last digit is not fluctuating, and based on the error analysis lecture, define what the error for that display is going to be. And so that's going to be your digital mass display error. And next is going to be the protractor. So right here is the protractor, and you just have to actually look at that angle, but I recommend that you zoom in to find out the value for the smallest tick mark, and that's going to give you the error for the protractor. So this is going to be the protractor here. So you'll get your errors, and don't forget to include the units for each of those instruments. Whatever those errors are going to be, make sure that they're converted into SI. That's the first part. And then the next thing is the definition of terms. So length is going to be capital L. Error and length is going to be sigma L. Mass is going to be variable m. Error and mass is going to be sigma m. And so on. You have these different terms here. And so you have the rest of the terms that we'll be looking at for today. And also, let's see here, AC, that's accepted, and EXP is going to be experimental. Okay, so that's the terminology. The next part is section 3, which is your FET setting. So it says that you have to go to FET and set gravity to Earth, and you're going to set friction to the 5th tick mark. So then you'll go here. You can change the gravity to whatever you want. Make sure you set it to Earth. And then friction, you want to set it to here. This is the 0 tick mark, 2nd, 3rd. Well, actually, no. Well, yeah, 0, 1st, 2nd, 3rd. So you're going to set it to the 5th tick mark, whichever one that is there. And make sure, just to be safe, so I know that you did it, enter those values here too. The value that you set the tick for gravity in the FET web page, and also the value that you set the friction to. You'll select it from that list there, whatever those are. And that's going to be it for the setting up for your experiment. So you're going to have friction set to a particular value. You're going to have gravity set to another value. And now you can begin the experiment. So here it says read procedure 2 in the instruction manual and complete section 5 and 6. So if you look at it, there's only section 4 and 5. So here this is section 4, and here this is section 5. So let's go to the manual. So in the manual, you can see right here, this is section 2. So I can't highlight the whole thing there, but everything in this section here, 4 and 5, you're gonna get the instructions over here in section 2. So you'll have to read that. But I'm gonna go over that myself here. So here it says you're gonna set the mass to, in the FET website, you're gonna set the mass to 1 kilogram and set the length of 0.7 meters. And you'll enter here 1 kilogram and then 0.7 meters. And you have to do the same thing on the FET website. So then you'll go to here, you're gonna set the length to, or the mass to 1 kilogram and the length of 0.7. So mass is already at 0.1, you're gonna set the length to 0.7. And now you're gonna be ready to begin the experiment. Just make sure you adjust the gravity to Earth and then friction to the 5th tick mark. And so now that you have it set up also, you're gonna have to read the manual and see what value of gravity that it says to use here. It should be written somewhere here, the specific value of gravity that you want to use. So you have to go ahead, you can actually see it here in number 5. So you just have to read the entire procedures in order to get that value for gravity. And you're going to enter that value here. And that's going to be your accepted value for gravity. Yeah, 9.8 something something. So I'll just leave it as that, 9.8. Whatever, however many decimal places is written over here in procedure number 5. And don't forget the units for gravitational acceleration. And now you're going to be ready to begin the experiment. So this is the part where I recommend that you follow what I show you here instead of what the manual says, because the manual was designed to do in person. But I think through this website, the way that I'm going to show you here is going to be a little bit more, make it go by a little bit faster. So you're going to have these different angles here. So you're going to change the angle and you're going to release the pendulum. And you're going to take 3 trials for each angle. So let's see here. So for the first one, let's go for 20 degrees. So you'll have to figure out the best way. So I'm gonna let you figure this part here. Is you're gonna have to figure out the best way to time it to measure 1 or actually 5 cycles. So what I mean by that is you're gonna let this thing go, set it to 20 degrees, and you're gonna let it go, and you're gonna let it vibrate 5 times, and you want to measure the time for it to vibrate 5 times. So then you'll just have to figure out a way to start your stopwatch and let it run until you count the time for 5 cycles. So the manual says to count the time at the bottom. I recommend, I was able to make it work by counting the time from release or from the highest position. So it's up to you. I want you to try to play with that to decide which method is going to work better. In this website here, there's also an option to include a trace of the vibrations, but I don't recommend that you use that because if you notice, as the traces are swept out, it's only going to show you for only specific intervals, and then it'll stop showing the trace for other intervals. So I don't recommend that you use this trace period. You don't even need the ruler there because you have the time measurements. So you're going to have to figure out a way to change the angles, release the pendulum, and then measure the time for this thing to vibrate 5 times. And you're going to do that 3 times. So for it to vibrate 5 times, so you'll measure whatever time that is, and you're going to enter that number here. So this was about 9 seconds. So 9.8 or 9.9, and then you'll enter, you know, your other value. So maybe this one was 10.2, and then this one was 9.5. So you're going to do 3 trials, and then you're going to change the value. So you're going to repeat this for 5 degrees, and then you're going to all the way to, I believe, 90 degrees. And you're going to just change the angle and measure the time for this thing to vibrate 5 times. The manual recommends one way to measure the time, but see if you can do it the way they do it. But I was able to figure out another way. But it's really up to you. You just have to measure the time that it takes for this thing to cycle 5 times. And you're going to do that for 5 degrees, 10 degrees, all the way down to 90 degrees. And don't forget to enter the units for the angle and then for the times here. So that's going to be your experiment. And the next part is going to be the calculations. So here you want to calculate the average of those 5 times. So you can just do equals and an average. And then drag it across these numbers here. And that'll give you the average. And next, you want to calculate the experimental value for the period. So here, you actually have to use an equation, and the equations are going to be defined at the bottom here. So here, this equation tells you that to get the period, it's the time for 5 cycles divided by 5. So that's what you'll do here. You're going to take this as the time for 5 cycles. So the period is going to be this number divided by 5. And that's going to be the experimental period. The theoretical period, you're going to read the manual and see what equation you're going to use to get to calculate the theoretical. So this is going to be in section 2 here. And this tells you in section 2 what equation you're going to have to use to calculate the theoretical value for the period. And you're going to enter that number there. And the last thing is to calculate the percent error. And the percent error is also defined at the bottom here, right there, percent error. So that's going to be the first part. You're going to change the angles and then measure the period for each angle. And you're going to compare the period for each angle, well, the experimental period versus the theoretical value. And you're going to try to get a relationship between the angle versus the period of oscillation. So that's going to be the first part of the experiment. The next part of the experiment, so we're skipping procedure 3. You're going to jump through procedure 4 through 6. So you're skipping here procedure 3, and you're going to jump to procedure 4 through 6. And so here, right there, procedure 4 through 6, and you're going to enter the values into section 8 and section 9. So section 8 here, section 9. So in procedure 4 through 6, it says here you're going to set the angle to 10 degrees. Don't forget the units. And then you're going to set the mass to 1 kilograms. So that means here, then you're going to set the angle to, you're going to keep the angle at 10 degrees for the entire experiment. You're going to set the mass to 1 kilogram. So the mass is already at 1 kilogram. So here, you're going to change the length. And the angle is always going to remain at 10 degrees. So you're just going to be changing the value for the mass. Excuse me, you're going to keep the mass at 1, but you're going to change the length for the experiment. You're going to have a small value. I think it's going to range from 0.3 all the way down to 1.5. Actually, no, 0.8. So the length are going to range from 0.3, 0.4, 0.6, and 0.8. So here, what you're going to do is you're going to keep the mass at 1. You're going to always release at 10 degrees. And again, measure the time for 5 cycles. So however much time it takes to measure 5 cycles. And then you're going to enter that number here. And you're going to do this 3 times. And the next trial, what you're going to vary here is the length. So you're going to change the length. You're going to go from, do this experiment for 0.3, and then 0.4, and I believe then 0.6, and then 0.8. So here you're varying the length, and you're keeping the angle the same, 10 degrees, and you're keeping the mass the same at 1 kilogram. And you're going to do the same thing. You're going to get your different trials, and you're going to enter your units for length and your units for time, whatever those are. And just like before, you want to calculate the average of these 5 values. So this is 0.75, and then let's say this was 0.7 or 89. So to calculate the average, you can do it by hand, or you can type equals and then average. Yep. Oh, well, I'll just do it H57. And that's the average. And to calculate the experimental period is just going to equal this number, since it's 5 cycles, divided by 5. And the theoretical value, again, you're going to look at your manual. So now this is in a procedure 4 through 6. So you're going to read procedure 4 through 6. So again, you're changing the masses, and you're measuring the time for 5 cycles. And so you're going to calculate the value. You're going to have to use the equation that they tell you to. It's either going to be equation 3.1 or 3.2 to calculate the theoretical period. You're going to put that number there. And then you're going to calculate the percent difference between this number and that number. So let's say that this was 1.9. This is going to be the percent difference between these two numbers here. And then you're going to repeat this and you're going to repeat what you just did here for the different masses for 0.8 or 0.6 and then 0.4. And now once you've completed this section, then now you're going to go to procedures 7 and 8. So it's the same experiment. We're just adding another part to the same experiment here. So actually you're done taking data after you completed this part here. So in procedure 7 through 8, this is just now how to linearize the graph. And the manual says to use this equation to linearize the graph. I actually recommend that you use the one that I refer you to. If you look at here, you're actually going to take the period divided by 2 pi and then square it. And that's going to give you a linearized graph. And so let's see here. So we're going 7 through 8 procedure. And so in section 10, you have those same lengths here that you have from before, right there. And then you have your experimental period here. So then this number, what this is going to be the experimental period divided by 2 pi and then squared. So you can do it this way. You can say it's going to equal a quantity squared. And what squared is equal to the experimental period and then divided by 2 pi. And let me try to zoom in here. I don't think I can yet, so let me just do it this way. So this is going to equal then quantity squared. And inside that quantity is going to be, let's see. Yeah, I'll just have to get the cell location. So the cell I want to get is, let's see here, K57. So you can do this manually, but I'm going to show you how to do this in Excel. So then this is going to equal quantity squared, K57, and then divided by 2 pi. So it's 2 times pi. In Excel, pi is capital Pi parentheses. And then you're going to calculate each of those corresponding the period for 0.4, the period for 0.8, and the period for 0.6. And you can calculate those numbers there. And then once you've done that, then what you're going to do is you're going to create a plot here of length on the vertical axis and this number on the horizontal axis. And when you do that, you're going to enter that plot here. And here, The reason why I recommend that you use this equation versus the one that the manual gives you is that the slope is automatically going to equal gravity. So once you get your slope here, then that's going to be the value, your experimental value for gravity. So the last part is to do the see how accurate you were in your measurement for gravity. And that's going to be in this section here. So here, the error in the length, that number is already defined up here. That's going to be whatever number you define here to be the error in the length. And I broke up the formula. So this is the same error formula from the last experiment. So there's two measured values. There's going to be the length and time. So this is going to be the error in the length divided by the actual length. And this is going to be the error in the time divided by the actual time. Take those two numbers, square them, and take the square root of those numbers. And so here I have it broken up into pieces for you. So this one here, this column can represent this set of numbers. And this column here, sigma t over t, is going to represent this set of numbers here. And so to calculate the error for g, it's going to be the experiment, your slope or your value for g, and then multiply by the square root of this number squared plus that number squared. And that's going to be your error for gravity. And again, don't forget to enter the units for length and these ratios here. And the last part, the value for gravity that you got from the slope here, you're going to enter that over here. So whatever the slope was, you're going to enter it here. And here you're going to choose the biggest value for g, for the biggest value for the error in g. You're going to enter that number there. And then this last part is going to be just a percent difference between your experimental slope and your accepted value for gravity, which was defined up over here, that number there. And there's one formula that I just use for my own purposes. It's just going to be the difference between the accepted and the experimental value for g divided by the error of gravity. And you're going to enter that number here. And after that, you're going to do the homework assignments. There's only 4 questions here. And for the homework here, the one thing you have to be careful, here you're going to enter a number. And only enter a number. Don't enter any units here. So don't enter like 88 seconds. So only enter a numerical value. And also don't enter any symbols. Like plus or minus. That's not going to work either. So only enter a numerical value into this cell here. And then the rest of them are going to be just multiple choice questions. So this completes the overview of how to complete the gravity lab on Excel. So don't forget that there's 3 components. There's the actual Excel file. And then there's the manual. That's where you're going to get the instructions from. And then there is this PhET website where you're actually going to do the experiment.